Welcome to my YouTube channel. My name is JONAS ACHUOBI. Today, we shall be discussing on parallel lines. Let's get started. Two straight lines, L1 and L2, in a rectangular coordinate are said to be parallel when they have the same inclination. By inclination, we mean the angle that a line sustains with the x-axis, measured in an anti-clockwise direction. So, if line L1 has an inclination theta and line L2 also has the same inclination theta, then we can see that line L1 and line L2 are parallel lines. Okay, it follows, of course, that parallel lines have the same slopes, which we shall establish very soon. If we consider these two lines, L1 and L2, with L1 passing through the origin, 0, so that means at this point the coordinates is or are P0, 0, 0. Consider a coordinate P1, x1, y1 on the same line L1, of course, where y1 is greater than 0. Then, on line L2, we have two other points also. The first point, or two distinct points, point P2, we coordinate x2, 0, because it's at the origin. So at the origin, y is 0. Along the x-axis, rather, y is 0. So this is x2, 0. And the third point here is point P3, x3, y3. Of course, from point P1, you can drop a line to the x-axis. And what will be the coordinate of this point? The coordinate is nothing but what? x1, 0. And we drop this other point, the coordinate here is what? x3, 0. Okay, so we have that triangle P, P0, and whatever is here. Let us call this P star. And the other triangle here are similar triangles. Okay, so from similar triangles, so we are saying that the two triangles are similar triangles. They are similar triangles. So from similar triangles, what do we know? We know that this side here, what side is this? This is rise, okay? This side is y1 minus 0. So this is nothing but y1. And what side is this? This side is run. This side is y3. y3 minus 0 is y3. This other side is what? 0 to x1. So x1 minus 0. This other side is what? P2 to this point is what? x2, x3. So this point here is x3 minus x2. So from our knowledge of similar triangles, it follows that the sides of these two triangles will be in a ratio, right? Yes. So from similar triangles, this side here, y1 over y3 is equal to x1 over x3 minus x2 from similar triangle. Now, we like to rearrange this equation and see what comes out of it. So, if we cross multiply, we're going to have y1 into x3 minus x2 equal to x1 times y3. Okay, so if we divide both sides by x1, we have divided by x1 divided by x1, and what we have there will be y1 into x3 minus x2 over x1 equal to y3. Again, if we divide both sides by x3 minus x2, then what we have will be y1 over x1 equal to y3 over x3 minus x2. Now, if you look at this closely, what is this? y1 over x1. Let's come back to this diagram. y1 over x1, rise over what? Over run. And from our lesson of slopes, rise over run is equal to what? The slope of line L1. So if I call the slope of line L1 M1, then y1 over x1 is equal to the slope of line M1. And then y3 over x3 minus x2, once again, rise over run. So if I call the slope of line L2 M2, then y3 over x3 minus x2 will be what? M2, which is the slope of line L2. What do we get from this? We see from all this that M1 is equal to M2. And what does this mean? This means that the slope of line L1 is the same as the slope of line L2. So we are saying here that if two lines are parallel, not only are the inclinations the same, but also their slopes. Okay, so we take note of this. Let us look at this triangle again. Triangle P, not P, and say P star. This angle is theta. This side is the opposite side, and this other side here is the adjacent side. We can relate the opposite, adjacent, and the angle in question using our mnemonic SOHCAHTOA, if you recall, SOHCAHTOA from high school, SOHCAHTOA. If you recall this, sine is what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you look at this, you see that this is opposite over what? Adjacent. So we can actually find tan what? Tan theta. So from there we can write that tan theta is equal to what? Opposite y1 all over adjacent x1. Are we there? What is y1 over x1 from here? Y1 over x1 is m1, which is the slope of line L1. This is equal to what? M1. So what we have, what this implies that M1, the slope of line L1 is equal to the tangent of the inclination of line L1. What we have here is just another formula which we use in finding the slope of a straight line. So apart from saying slope is rise over run, we can also say that slope of a line is what? Tan theta, where theta is the inclination of that line. Since we have said here that M1 and M2 are equal, so it also follows that the slope of M2 is also the tangent of theta. What can we make from of all this? It means that if we have a third line here that is parallel, its slope will also be M3 equal to tan theta. From this, we can conclude that, okay, given any line, okay, that the slope of the line M is equal to what? The tangent of theta. So this is the second result we got from here. We have said that, okay, that if two lines are parallel, then their slopes M1 and M2 are equal. If two lines are parallel, we have also said that their inclinations are the same. And we have also obtained that the slope of a line can be given in terms of the tangent of the inclination. Now, we are going to demonstrate how this formula can be used in solving some problems. We take the first example. Find the inclination of the line passing through the points A 4,6 and B 1,3. The question is find the inclination. And what is inclination? This simply means the angle that this line makes with the x-axis. We call that angle theta. So this is what we call the inclination of the line. We are asked to find the value of this. Now, from what we did earlier, we established that the slope M of a straight line can be given as the tangent of its inclination. But in this case, we do not know what the value of theta is. But this straight line passes through 2 points, through 2 points whose coordinates are given. So from these 2 points, can we find the slope? Yes, we can. So what is the slope? The slope m is what? y2 minus y1 over x2 minus x1. What is y2? y2, let's call it x1, y1, x2, y2. So y2 is 6 minus y1 is 3 all over x2. x2 is 4 minus x1 is 1. That gives us 3 over 3. And the answer is 1. So coming back here, we now put 1 for m. So the slope m is now 1. So we have that tan theta is equal to what? 1. To find the inclination theta, we now say that theta is equal to the arctan or the tan inverse of 1, which is what? 45 degrees. Therefore, the inclination is equal to what? 45 degrees. Okay. We take the second example very quickly. Question says, use slope. It should be slopes. Use slopes to determine whether the point 8, 0, minus 1, minus 2, minus 2 and 3, and finally 7, 5 are vertices of a parallelogram. Are vertices of what? A parallelogram. Now, I've sketched this parallelogram already on my Cartesian plane. So the first point A, so I have here 8, 0, 8, 0, minus 1, minus 2, minus 1, minus 2. Here's the point. Minus 2 and 3, minus 2 and 3, and then 7 and 5. 7 and 5. So when you join this, when you join the 4 points, what you have is this shape. The question is, you should use slopes to check whether this is really a parallelogram. So what do we do? Now, from our slopes, we know that the slope of parallel lines are what? Are the same. That means, now for example here, line AB is parallel to line DC. And of course, if they are indeed parallel, then we expect their slopes to be equal. On the other hand, line AD and line BC are also parallel lines. And if they are indeed parallel lines, using our slopes, we know that their slopes should also be what? Equal. So how do we go about this? We simply calculate the slopes of the lines. So we start with line AB. I call the slope of line AB, say MAB. That is slope of line AB. And what is the slope of line AB? y2 minus y1 over x2 minus x1. x1, y1, x2, y2. So y2 is 5 minus y1 is 3 over x2 is 7 minus x1 is negative 2. So that is negative, that's 7 plus 2. So that will give us 5 minus 3 is 2 over 9. So the slope of line AB is 9. So slope of AB is 9. Let us now check the slope of the other parallel side, line DC. So slope of line DC is equal to y2 minus y1 all over x2 minus x1. This gives us, I call here x1, y1, and call here x2, y2. So y2 is 0 minus y1 is minus 2, so that is 0 plus 2 over x2 is 8 minus x1 is minus 1, so that is minus is plus 1, and that gives us 2 over 9. What do we observe? We observe that the slope of line AB is the same as the slope of line DC. And what is the slope? 2 over 9. This tells us that these two sides are indeed parallel. But we cannot conclude that the shape is a parallelogram until we are also sure that the other two sides are indeed parallel. So we compute their slopes equally. So slope of line AD So MAD, slope of line AD, is also y2 minus y1 over x2 minus x1. So I call here x1 y1, x2 y2. So my y2 is negative 2, so minus 2 minus y1 is 3 minus 3 all over x2 is minus 1 minus x1 is minus 2. So minus 2 is plus 2. And this gives us minus 1 minus 2 minus 3 is minus 5 all over what? 1. And that is nothing but what? Negative what? 5. That is slope of line AD. Lastly, we compute also the slope of line BC. So MBC, that is slope of line BC, is also y2 minus y1 over x2 minus x1. This is equal to, so this is my x1 y1, this is my x2 y2. Y2 is 0 minus y1 is 5 all over x2 is 8 minus x1 is 7 equal to 0 minus 5 is minus 5 over 8 minus 7 is 1. And the slope once again is negative 5. So what do we conclude from here? We conclude again that the slope of line AD is the same as the slope of line what? Of line what? BC. So we have seen that the slopes, the slope here and the slope of this other line are equal. The slope of line AB and the slope of line DC are also equal. So what do we conclude? We conclude that the quadrilateral A, B, C, D is indeed what? A parallelogram. Is a parallelogram. Okay, so we have just shown how we use slopes to determine that the vertices of this shape given to us are indeed a parallelogram.